go. Going live. And we're live. Great. So I'm Mike West. Work for Addresscloud. Last time I did a talk was a long time ago. It was on using a blackboard and chalk. That's how long ago it was. I used to be a mathematician, but now I'm a software developer. I've been for 6 or 7 years. Look, now I'm making PowerPoints, which is amazing. So I'm going to talk about PostGIS LDB rasters in AWS Batch. So let's start. So imagine the problem. You're given a big raster, and we want to smash lots of polygons against it. So we're going to try and solve this problem today. So I'm going to tell you what I mean by smashing lots of polygons. And let's start with the raster. So I've made a raster on the right. I don't know how easy this is to see from the back, but does anyone want to have a guess what this raster is? It's a raster that I've put on top of an OpenStreetMap. Does anyone want to guess what this raster is, what the data is? No guess.
We've got one here, population density.
Population density, yeah, that's a good one. It's not quite that. It's not air pollution. It's actually a heat map of Greg's in the UK. So this was inspired by an article from the Tab a few years ago. So I should put that disclaimer in there. I do read other publications. So yeah, we've got a big raster. It's all over the UK, and the red spots are when you've got a lot of Gregs, and the amber spots are a fewer, and then where you've got no data report, there are no Gregs there. Useful information if perhaps you're buying a house, maybe you want to be in the red spots. So, what do I mean by smashing a polygon against a raster? So I've zoomed in on leads, and I've drawn a polygon around leads. And sorry if you're in horse support Burstall, but you didn't make the cut. What I mean by smashing a polygon against this raster is this raster has got a load of values in each grid cell of the raster, and I want to know within the polygon what are those values. Simple enough process or function that you might want. And that's okay. For one polygon, you might have a process to do that, but we want to be able to efficiently do that for a lot of polygons. So, for instance, there are 1.8 million postcodes in the UK, or around 29 deliverable addresses in the UK. It's quite a lot of polygons, smashing against one raster, that's all well and good. But we want to do it quickly, and we want to do it in a repeatable fashion. We spoke about different ways to do this, and Mark read a blog post by Paul Ramsey that talked about a process of using a raster and then printing that by PostGIS. And he described this problem in general as embarrassingly I should have practiced saying this word, shouldn't I? Parallelizable. Easier to write down than say it. So yeah, that makes sense. If you've got a process for n polygons, maybe you can do it, in several strands across several lambdas or whatever. However, we're going to be talking about PostGIS today. Why are we proposing to do this in PostGIS Day? Well, it's PostGIS Day today. Number one. Thoughts on PostGIS Day. So what is that? There's the URL key, find out more about it, but it's basically a celebration day for PostGIS. There is also an event today where it's an online event, and the talks will be recorded, and you can go see them afterwards. Go check out this URL, postgisday.rocks. Obviously, that's not the actual reason that, a couple of years ago we decided to go with this piece of tech. Real reasons are, if you've got your raster being fronted by PostGIS, then you can use the functionality from PostGIS to do whatever you need to do. And there's lots to be said for the fact that, I mentioned it earlier, that all of our data is kind of sat in PostGIS as well. So that's where our inputs are. That's where we've got polygons for every address in the country. We've got polygons for every postcode in the country. Our data is in there. We want the outcome of this smashing results to be in PostGIS as well. Let's try and do our processing in PostGIS. So once we've made that decision, then we've got another decision, of course. How do we store this data? So I've got the geotiff, that's what I rendered on the first slide, the second slide. And there's actually two mechanisms to be able to store this or allow PostGIS to query that data store. So you can do something called an in-DB raster, where PostGIS actually takes your data and stores it inside the database in a PostGIS friendly format, or you can keep your raster outside and you can what's called register your raster with PostGIS, and PostGIS knows how to query it and return the relevant results that you need to do. So all of that functionality is there, but you don't have to store the data for the raster in two different places. So what we're going to do is we're going to take that raster that I demoed earlier, the Greg's raster, and we're going to make it ready to be registered in a PostGIS database. That process is roughly as follows. We convert the raster to a tile format. I'm going to run through what all of these mean. Put that raster near to a PostGIS database. I'm going to register that raster with the database, and then it's ready to query. So let's look at that first step. Convert raster to tile format. So we've got a geotiff, Greg's heat map, and there's, GDAL has great bit of functionality to query that data set, so GDAL info, and we can get a whole load of text. I don't think I've ever run it against Greg's heat map. Most of it I didn't really care about for the purposes of this talk, but what I have thought, or what I do care about, is what I've highlighted, which is the block equals 574 times 3. Now this block is essentially a tile in that data. If I just want one value near leaves, so I should say that this green polygon down here is a representation of what that block is. If I just want one value near leaves, I have to retrieve everything out of the file, potentially decompress it, just to receive this one value. It doesn't seem an efficient way to do things, especially with the type of queries that we're making to get this data set. You've got a polygon that traverses, I don't know, all of leaves, like in our example. We're going to have 3 or 4 blocks the entire width of the country getting data out. Now, perhaps Dave, JVA, is looking at the width of this raster being 574. That's because we've got resolution of 1 kilometer. It's not really a problem at this resolution, but at a resolution of 5 meters becomes a bit of a problem, and that's actually quite a lot of data. So it's actually quite nice and easy to tile it in a different fashion. You can just use GDAL. So with a minimum version of 3.1, you can use an output format. That's what this -OF is of COG. That's this cloud optimized geotiff that's been bandied around a lot. It's actually an alias for loads of other aliases or attributes that this data set's going to end up with. One of those is going to be tiled. One of those is going to have overviews, like Tom mentioned. So we are translating translating our badly arranged geotiff into a better arranged geotiff, and the blocks come out as we've done a 16 by 16. By default, I think it's 2 by 6 by 2 by 6, but I've got a block size of 16. The reasons for that, just for demo purposes, because I've got a 1 kilometer resolution, and 2 by 6 by 2 by 6 is probably 8 blocks across the entire country. But yeah, this polygon now represents a block in this new format. So if you query that polygon we had earlier of leaves, potentially you're getting a much smaller subset of the data out, and you're doing it a lot quicker. So that's prepared the raster to play nicely with the kind of queries that we're talking about. It's filed optimized. So one thing that you might consider is putting it into a bucket. That's what the AWS S3 copy, Greg's heat map called it, put it in the run bucket. bucket names are global. I have no idea if this exists, so I just made it up. And a perfectly viable solution to using out DB rasters is to have your rasters have a bucket and then front that by an RDS instance. So this is a managed solution by AWS, and it's got PostGIS, great. And you can do this out DB thing where you say, I'd like to register a raster in an S3 bucket back onto that raster, and I can do any kind of query that I might be able to do on a normal raster inside of PostGIS database, but my data doesn't exist in RDS. That's back onto data in S3. But for demo purposes, I didn't put this in the bucket. I just did locally. That's fine. So the commands you see later will be for getting into a local database. So then we need to register that raster with the database. So if you've got database, if you want to install PostGIS, and then separately PostGIS raster. It used to be bundled in with PostGIS, but now you need to allow the PostGIS raster extension separately. And then you actually explicitly need to say on the database, on my database set, PostGIS enable out DB raster to be true. So you actually need to enable this bit kit. And then this last line, we're setting GBEL enabled drivers to enable all. Don't think this is strictly necessary if you're doing it locally. And I'll say a bit more about this stuff when we talk on the next slide. So these are some prerequisites. The database is set up to handle this out DB raster, but it doesn't actually, it's not registered yet. To do that, you need to use a bit of a command line tool, raster2 SQL, which is bundled in with PostGIS. And there's a load of options here. So we've got the estimate of the data that you're ingesting. We're saying it's tiled. Now, this is a bit confusing because we've tiled our data in an appropriate fashion. We're actually going to be tiling inside the database the data as well. So it's hopefully become a little bit clearer. We're going to delve into what's actually in the database on the next slide. So, but bear in mind, there's two tilings here. There's one in the data in the raster, and there's one actually in the index or in the database with the pointer to that data. And then we create a GIST index, so it's fast to do geospatial queries, and the -R, big -R means we register only, so it's an out of DB raster, not actually ingesting the data that's in Greg keeps that context here. And it's ingesting to a table called Greg's. And you have to pipe that into PSQL, but I don't want to focus on that. So if you were doing this into the cloud, you need to change where it says Greg's heat map cog.tit. So if you were trying to talk to an object that's in S3, then you would have to use this virtual file system that GBEL has, BSI curl, and then give it a URL. So what this does, it allows PostGIS to use a HTTP interface to talk to an object. And as Tom mentioned earlier, S3 is basically a web server. It allows you to make requests to objects and not just house those objects. So what you've got is a PostGIS instance with an ability to make HTTP requests to an S3 bucket. Of course, this requires this PostGIS really requires this object to be open and not be protected in any way. So once we've done that last step, raster to PGSQL, then we've got some data in the database, and I'm just going to run through a couple of queries. So let's start from Greg's. So Greg's was the table that we end up with. I'm just getting the first element here. And the columns are RID and RAST. RID is just a random identifier. I've got the first element, right? And then I've got a random, well, it's not random, but I've got a long string of numbers and letters, which mean nothing to to me particularly, but will more in the next slide. And then I've got counts start from Dregs. I've got 764 of these guys at the top. So what these are the tile dimensions. So they're essentially like mini rasters in your database, or pointers to the raster. If we just have delved a little bit more into this raster column, so there are a couple of PostGIS queries or commands that you can run in PostGIS. st_metadata on RAS and st_band metadata on RAS. And this just gives you a lot of metadata about your raster that you'd expect to see. So each individual row in that raster table that we've created has, all the things you might expect to see on a raster. So where it is in the world at the left X and at the left Y, how big your tile is, 16 by 16. And you've got the resolution as well, which is 1,000 meters, and you've got an S-rid. And then on the bottom, the bit that I want to draw your attention to is path, which is just a reference to some local file rather than actually housing any data. It's just storing a pointer to where it needs to query. Another query. So let's go back to the original problem of smashing polygons against rasters. I've now got my lead poly in the database. I've just ingested that using ODR to ODR. Let's ignore most of the top line. I'm looking at the raster table again, that raster table that I've created. I've got my lead poly, and what I'm looking at is the intersection of the geometry of the lead poly with some convex hull of the raster. So if you think about each row in this database, like a little mini raster, what this last line is saying, find me the mini rasters that intersect this lead polygon. Okay, so when I've got those, I then, let's ignore value count for now, I've got an ST clip, and it's just saying that mini raster, clip it by this geometry. So get rid of the values outside of that lead polygon geometry, and then get me a value count. What does that mean? Let's look at some results, because I think that's the easiest way to see it. There it is. Right. So remember that what we're looking at is essentially how many Gregs there are within a certain radius. I think it's around 10 kilometers. So somewhere in that raster grid, within that polygon, there is a value of 25.42, blah 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 blah, and only one of those grid cells inside that lead polygon has that value. This just gives us an efficient way to store it if you've got loads of values with the same amount. For instance, if you've got flood scores or something, a lot of those flood scores might be 0, and you don't want to have to store a different row for every single 0. So what you might do is put a 0 there and a count of the number of zeros within that polygon. Which is great. So if we look at the architecture again, so I said this is a perfectly viable way of managing this data. However, and it's great that RDS is managed. It takes some of the headache out of the development process, but there's little or no control over the PostGIS version that might be in the RDS instance. And we've hit a wall before where there's functionality that we want, and that's not been in the RDS instance that we're talking to. Also, what we're doing here is we're requesting backend data from S3 over a HTTP protocol. That's not necessarily going to be the quickest thing in the world. We're having to handle scaling. We're potentially doing a lot of queries against an RDS instance in parallel, and we might have to scale our RDS instance. Sure, there are serverless options to PostGIS in AWS, but we find that those serverless options are even further behind in terms of PostGIS, so don't really necessarily count that as a contender. And also, we want the entire process described above be automated. So this process of we get a raster, we get some polygons, and then all we want to press a button, and at the end we want the values for each polygon. We want the values of the raster inside those polygons. Now, at some point, if this is the way we're going to do it, we need to register our raster inside this RDS instance in an automated fashion. You need to spin up a job or a Lambda or whatever it might be. But if we're doing that, we might as well do something like this, where we're using a piece of tech called AWS Batch. What Batch does is it runs jobs in Docker containers, and because we can control a Docker container precisely, we can install exactly the PostGIS version that we want. We can control that environment completely and do what we want. So that's what we do. We store PostGIS in there, and then into a Docker container environment. And then we copy the raster from S3 to that Docker environment. We register it as an out DB raster, and yes, okay, we've got 2 copies of our raster, but if we did an in DB raster, we would have 3 copies of our raster lying around. And then also in this batch environment, we load polygons of interest to that instance of PostGIS, and then we do this process of slashing these polygons against that raster in parallel. And because a batch spins up these Docker containers and actually handles a lot of the scaling here, we don't have to worry about that so much, which means that we can actually do effectively quite a lot of these results in parallel. And that's it. So thank you. Questions?
You showed using BSI code to access the raster on S3.
Yep.
Is there a reason why not to use BSI S3 to access the raster on S3?
Only that I was not aware of it existed. So yeah. But
well, it can be a bit finicky with credentials, so it might. The answer might be still.
Okay.
I don't know.
So that will handle like IAM credentials.
Yes. Yeah. It can be a pain with rotating credentials. But I guess that's usually long term. But you can give it a go, but you've got something else anyway, which is a bit different there. So.
Yeah.
So what do you say is the pros and cons of using PostGIS for these kind of queries versus, say, a Python library like GDAL or Rasters?
Yeah, I mean, Rasters is great, and it does it really quickly. And you've seen, I don't know if you're using Rasters for.
We're using GDAL.
Yeah, that's right. But yeah, it does it really quickly. But I think the big thing for us is all of our data exists in PostGIS, and we want our inputs to be in PostGIS. We want our outputs to be in PostGIS. So we might as well do our processing in PostGIS if we can. If you were to create a Lambda, or how many Lambdas, doing a process like you demonstrated, then we'd have to somehow get our data out, of this PostGIS database, pass it to the Lambdas, and then somehow get it back in. So for us, conceptually, it's a much easier way of doing these kind of queries.
Does PostGIS tile thing, or do you need to tell it to do that?
You need, let's have a look. Spatial auto, I can't remember what the docs say, but they say, raster 2 PG SQL, you handle it for me, like you pick the best tiling, but you can specify a different tiling if you wish. But yeah, I like code that has opinions, so I'm quite willing to listen to this.
You probably want to tile by roughly the size of a building footprint or thereabouts. No?
Sure.
Yeah, I am.
That probably would only affect the size of the data, the resulting database. But if that's not a concern, then yeah. But yeah, you're right.
It makes the spatial index really big. You do that, and then you look at the queries as well. The post, like basically the tiles and PostGIS are like a spatial index.
Yeah.
That then are indexed on like quad tree, what the tiles in the raster. So a bit of work to do to optimize what that is. Also works quite well.
Cool. We've got 2 minutes before the national talk, so I think we'll set that up. Thank you.